Hey, Algebra 1, I've been talking about simplifying radicals, so I'm going to run us through a few for homework. I'm going to start on the left, and hopefully you will work all the ones on the right, and we will come together tomorrow and check your progress. Remember, when you're simplifying radicals, it's important to remember, or at least keep in mind, all of the immediate perfect squares. This makes the process much simpler if these are memorized. If these are not memorized, then it will be slightly more difficult. So when you're thinking about factors of 18, and really you want factors where at least one of them is a perfect square on our list up here, 18, that's either 18 times 1, 6 times 3, or potentially 9 times 2, and really wanting to lock in on one that's a perfect square. So the square root of 9 would be 3. 48, you may be tempted to think about 4 times 12 since that's on the multiplication table. However, 12 has a perfect square in it, 4 times 3, so that's not the biggest perfect square. We should really lock on something like 16. So I'll demonstrate the way that I look for these if you are a heavy calculator user. 48 divided by 2 would be 24, so there's no reason to divide by 25 or 36. We want to divide by perfect squares lower than 24. And so the first one that's lower than 24 would be 16. And you see that 16 gives you 3. 16 times 3 is 48. So the square root of 16 would be 4. And then that square root of 3 is left over. 125. 125, anything that ends in 25, 50, 75, I'm really thinking about 25. So that'd be 25 times 5, where the square root of 25 is 5. So I don't want to do too many for you. I want to just encourage you to use the perfect squares, use division, and simplify as many as you can. And let's take a look at some of the more difficult ones. The more difficult ones are when you have variables. So I'm going to start with 108, and I'm going to start dividing by perfect squares that are lower than half of the number. Okay? So I don't want to divide by like 64, because there's no way that 108 divides by 64. It's more than halfway up. So I want to start by dividing by numbers less than 54, like 49. It doesn't work.
Mr. Tune,
Yeah, oh, thank
my
you.
bad.
So now I'll try the next perfect square, 108 divided by 36. And this was what I wanted, 36 times 3. 36 times 3 is 108. And 36 is obviously a perfect square that will simplify. So that is 36 times 3. And today, the last few days, we've been talking about how the 1/2 power is the same as a square root. Like, that is the same idea. The 1/2 comes from the fact that 25 is to the 1 power, and right now we're talking about a square root. Okay? So that is why this next part is important to think about, as you are halving 12. When you're thinking about power rules, I could say instead of writing the square root symbol, I am doing the 1/2 power on this, and powering a power would be multiplication, and 12 times 1/2, that would clean up to be x to the 6th. So we've got square root of 36 is 6, half of 12 is 6, and then the square root of 3 is left over. Now odds are just a little bit different, but really the same, because we want to ultimately divide by 2, but odds aren't divisible by 2 like evens are. So we have to kind of break that number up a little bit. So let's do 216 first. 216 divided by 2 is 108. So I do not want to try like 121 or 144. I want to move down the list from numbers lower than 108. Now obviously, hopefully you don't think 100 is a factor of 216. But just go ahead and try all the ones that you think it could be. 216 divided by 64. 216, let's jump to the point. Let's divide by 36. There we go. So 36 times 6 is 16. But just like I broke this up, I'm wanting to break up this n to the 25th. And I want the biggest possible even that could give me that division of 2. So I want to break up n to the 25, understanding that when you multiply variables, they really add together. So I want n to the 24th and then an extra n. So now what I've done is I've basically separated the radical into parts where if you put them all together, you would have what you started with. But now I want to basically extract everything that simplifies. The square root of 36 is 6. Half of 24 into the 12. Now what's left over can just go back together inside one radical. So go ahead and give the other ones a shot, 15 through 20, trying to basically work through these. And maybe I'll do one of the ones at the bottom just because it is 2 variable. So 112 divided by 2. I'm going to look for perfect squares that go into 112 below 56. Maybe 49. Nah. Maybe 36. Nah. I don't think 25 will go in. I really don't think 16 will, but I'll give it a shot. And I was wrong. 16 times 7 is apparently 112. So I will use the square root of 16 times the square root of 7. And the even, k to the 16, I don't necessarily want to mess with that one. Because when I simplify, I will just divide that power by 2 to extract it, but I don't want to affect it. But what I do want to affect is the odd. So I want to give myself just a little more room here and say, well, I really want 2 things that go together to be this v to the 21, where I'm getting the largest possible even power that I can. So we're just going to bump that down by 1. And now I can simplify. This is 4. This is 8. This is 10. Again, I'm saying 8 and 10, but it's really k to the 8th and v to the 10th. But what you're left over with is the 7v, and there's your answer. Hopefully this was helpful. Give the rest a shot, and I will check your work tomorrow.